Okay, very good afternoon, my dear learner. Today my topic is the phase rule. We are actually have to concentrate on one component system, that is water system. But before we switch on to this particular one component system, we must know that what is phase rule, what are the terms included in it, for example, component, degree of freedom and phases. All these things we have to take into account. So first of all, without wasting time, we should start with the phase rule. Now what is phase rule? It was first presented by Gibbs in 1875. He also proved this thermodynamically. That also that is an entirely new topic. Or here we are actually being defining what the phase rule is. It is very useful. Now what's the utility of this particular phase rule? It is very useful to understand the effect of intensive variables. I have particularly the word used intensive. Intensive variables such as temperature, pressure or concentration on equilibrium between phases as well as between chemical constituent. Now what does a particular word intensive property means? Intensive property, there are two kinds of properties, intensive and extensive. Extensive property is dependent upon the mass. Their value depend upon mass. It means if mass changes, extensive values, extensive properties also changes. But it is independent in the case of intensive properties or intensive variables. For example, temperature, pressure and concentration is not actually being dependent upon the mass. For example, temperature हम कह रहे हैं इंटेंसिव वेरिएबल है, चाहे हम एक ग्लास पानी को बॉईल करें, चाहे हम एक बाल्टी पानी को बॉईल करें, the boiling point remains the same. Now, it is used to reduce the number of, now another utility of the phase rule is, it is used to reduce the number of degree of freedom for a system, sometimes called variation of the system. Now, what do you mean by the degree of freedom? We will deal it separately. First, if we will move on to what does it say. What does the phase rule actually say? When the equilibrium between any number of phases is influenced only by temperature, pressure or concentration, not influenced by gravity or electrical or magnetic forces, degree of freedom of a substance is related to the number of component and phases. टेम्परेचर, प्रेशर और कंसंट्रेशन अगर हम कांस्टेंट करते हैं तो फेस रूल में जो डिपेंडेंसी है देयर कम टू बी एन इक्वेशन दैट इज f plus p is equal to c plus 2 या हम नॉर्मली बोलते हैं f is equal to c minus p plus 2, that is almost the same thing, just switching it over करेंगे तो दोनों चीज़ें एक ही हैं. तो फेस रूल हमें एक इक्वेशन देता है दैट इज f is equal to c minus p plus 2. Now, how it influences our system? What is the utility of the system? Actually, हम करते क्या हैं? फेस सिस्टम में अगर हम आपसे कोई सिस्टम कहें कि आप इस कमरे में जो सिस्टम हमने इस्टेब्लिश किया है वही कहीं और किसी और जगह अगर हमें सिस्टम का इंस्टॉल करना पड़े तो किन किन चीज़ों का हमें ध्यान रखना पड़ेगा कि वही सेम सिस्टम वी कैन फॉर्मुलेट इट देयर ओनली. हम कुछ कंडीशंस और कुछ कंडीशंस बताएंगे, उन कंडीशंस या वेरिएबल्स हम बताएंगे जिसको हम ध्यान में रखेंगे और उसी तरह का सिस्टम हम कहीं और भी कंस्ट्रक्ट कर लेंगे. तो दिस इज हाउ एक्चुअली द यूटिलिटी ऑफ द फेस रूल. वो हमें बताता है कि हमें कहाँ किन किन चीज़ों का ध्यान रखना है so that we will be able to form a particular system in another place. Now here in this particular phase rule, we have used three terms, that is what degree of freedom, phase and component. So we must know all these three terms separately, then we will be able to come out some conclusion. Now what is phase? Phase is defined as a homogeneous and physically distinct part of a system having all physical and chemical property the same throughout the system. A system may consist of one phase or more than one phase. Now what the physically हम कह रहे हैं, chemically और physically वो एक जैसे होते हैं पूरे सिस्टम पे. Physically डिस्टिंक्ट पार्ट, अगर हम सिंपल शब्दों में कहें तो फेस आप कंसिडर कर सकते हैं, सॉलिड, लिक्विड, गैस आप देखते हैं, these are the three phases. Now it is not always so that there are only three phases that could possibly exist in any system. More than three phases also exist. Now you will ask yourself, how come there is only three phases, solid, liquid and gas, and how come more than that phases will be also be present? Yes, of course. In the case of solid, if crystal systems are different, then one solid state can be differentiated into other phases because they are physically and chemically different in that case. So we will study in water system, eventually one component system की बात करें तो one component system में sulfur भी आता है, water भी आता है, and water is having only three phases but sulfur is having four phases. That we will also get to know कि क्या है. अगर हम सिर्फ फेस की बात करें तो हम कह सकते हैं कि फिजिकली डिस्टिंक्ट ऑफ अ सिस्टम है, डिस्टिंक्ट पार्ट ऑफ अ सिस्टम है जिसकी फिजिकल केमिकल प्रॉपर्टी सेम है, उसको हम फेसेस बोलते हैं. I have taken few examples also. A system, any liquid, water, obviously liquid है, water chemical constituent है और वो liquid state में है यानी पानी है, and it is a one phase system. अगर उसी लिक्विड को हम बॉईल कर दें तो वाटर वेपर विल बी आल्सो बी देयर इन दैट पर्टिकुलर सिस्टम, दैट इट विल बी कॉल्ड एज अ टू फेज सिस्टम बिकॉज वाटर वेपर एज वेल एज the water or the liquid is also present there, so it will supposed to be the two phase system. In the same way, if water vapor and solid isotope, all these three phases are also present, but the condition is minded, the phase equilibrium, the very important condition is that all the phases which must be present, they should be in chemical equilibrium with each other. If they are not in equilibrium, you cannot apply phase rule on any of the system. We were just considering that particular system which is in equilibrium with each other. So if all these three phases are in equilibrium with each other, then that particular system is said to be having three phases. ठीक है, तो this is all about phases. Now what about component? अब component कैसे लें? Basically हम यहाँ पर least number of component की बात करते हैं. अगर हम सिंपल शब्दों में कहें तो component is a chemical identity. किसी भी चीज को अगर chemical constitution उसका same है, then it will be considered as to be one component. But here the definition of component is not what the number of chemical constituent is about. हम ये नहीं कह रहे हैं कि इतने component chemical identities हैं तो इतने component होंगे, but नहीं. In this particular phase rule equation, what the component is, least number of component which must be required to express that particular system is component. तो यहाँ अगर एक ही है तो obviously एक चीज हमको बतानी ही पड़ेगी, that is one system. लेकिन जब बेसिकली तीन या तीन से अधिक कंपोनेंट होते हैं, केमिकल आइडेंटिटी होते हैं, तो somehow they are related to each other, कि उसमें से कोई भी एक हम नहीं बताएंगे तो उसकी जो वैल्यू होती है वो फिक्स हो जाती है. ठीक है, तो instead of having three, we just can take only two component because two component are sufficient to explain that particular system. So we are actually यहाँ least word I have used in the definition, the least number of independent chemical constituent. So least number, कम से कम हम कितना किसी सिस्टम में बताएं कि हमें पता चल जाए कि उस chemical identities हमको बतानी पड़ेगी just to explain that particular system. For example, water has three phases, solid, liquid and gas, and at a particular point they all three are in equilibrium with each other. So we can say that maximum number of phases that particular system can hold is 3, but all these three phases can be explained by only chemical constituent of water, that is H2O. So least amount of a component that we need to express that particular system is H2O. In the same way, I am talking about one component system, sulfur. In sulfur, actually maximum number of phases which can exist is 4. Orthorhombic, it's monoclinic sulfur, rhombic sulfur and liquid vapor. means solid has again been divided into two, rhombic sulfur and monoclinic sulfur. But only three phases can coexist altogether, although there are four phases. Total number of phases which is present in the sulfur system is 4, but maximum phases that may be present in equilibrium is 3. Any 3 of them will be in equilibrium. We have to study a phase rule diagram to explain more this part, but right now we are actually concentrating on water system. Now we move another term, that is degree of freedom. Degree of freedom means what? कि कितनी हम उसको लिबर्टी दे सकते हैं कि वो डेविएट कर दे. नंबर लीस्ट, यहाँ पर हमेशा लेस की बात करते हैं. Least number of component, least number of variable factor that has been required to explain that particular system. Degree of freedom, it can be defined as least number of variable factor that has been required or specified to identify that particular system which is occurring in a that we have already been formed. Degree of freedom means how much variables, how many variables that could be defined here. Here, if only one variable is required to define the system, that will be termed as monovariant. Only one is needed. If there are two factors, means pressure, variables are what? Pressure, temperature, concentration, these are the variables. If for defining any particular system, more than two variables, then if one variable is required, then it is monovariant. If two variables are required, that is bivariant. If three variables are required, they are trivariant. And if no variant is required and that is self-defined system, then this monovariant system. We will talk about this monovariant system in the water system. Now these are the three phases. I have summarized this particular phase rule in one component because here we have to specify more than one component system. So if number of phases 1, then degree of freedom is true and the system is bivariant. We have calculated what we actually do here in one component system. The value of C is fixed and P and F are varying accordingly to the equations. F is equal to C minus P plus 2. If we put the phases 1, then there must be 2 degree of freedom, and if 2 phases are present, 1 degree of freedom, and 3 phases are present, that no factors are responsible to define that system. I have summarized this. Now we come to the diagram and then it will be more clearer. Now here you look, this is a particular phase rule diagram of water system. In this particular diagram, you will find 3 things. Now what are those 3 things? First, these are the lines, and here these are the areas, and this particular point where all the 3 equilibrium phases are present. So in the line only 2 phases are present. Across this line CT, you find solid and liquid are in equilibrium. Along this TCT line, liquid and vapors are in equilibrium to this particular point, and in the same way AT line, solid and vapor are in equilibrium. But at point T, that is all the 3 phases are in equilibrium. Lines are having 2 phases, and the area CT, TC and ATC, this particular area and this ATC area, in areas only 1 phase is present. In line 2 phases are present, and at point P where all the 3 lines are merged, it has degree of freedom 0 because it is having all the 3 phases. At the triple point, this particular point is known as triple point, that has been denoted by T, and this triple point means what? Triple means 3 phases are present, and by applying the phase rule, if the component is 1, phases are 3, the degree of freedom is 0. It means it is a self-defined system and no variation is actually being required. If I say this is the triple point and I have to construct that particular system anywhere else, then we will just simply have to go this particular triple point and all three faces will almost come together except हमें इसमें कोई भी वेरिएबल डिफाइन करने की बिल्कुल भी आवश्यकता नहीं है. Now what are the advantages? अगर ठीक है, we have defined the face rule, we have understood the component, faces and degree of freedom. But what might be the utility of this particular face rule? Now first and foremost, face rule is applicable to both chemical and physical equilibrium. It is applicable to microscopic system. No information is regarding about molecular and microsystem. We are not talking about the amounts, we are not talking about this particular molecular structures and all. We are simply calculating the values. हम सिर्फ numbers की बात कर रहे हैं. Variables in terms of number we are talking. Which variable is there? What kind of variable is there? We are not talking about that. We are simply behaving in numbers, numerous में बात करते हैं. Number कितना है? We are conveniently classified equilibrium state in terms of phase, component and degree. हम किसी भी सिस्टम को phase, component और degree of freedom के terms में explain कर सकते हैं और कहीं भी उसको construct कर सकते हैं. That is almost very simple. The behavior of the system predicted in different conditions. If we changes the system, we are able to define that particular system. For example, अगर कोई point water phase rule diagram है, उसमें line से अगर हमने pressure temperature को club किया, देखा ये pressure है, ये temperature है, तो हम आसानी से बता सकते हैं कि उस particular temperature और pressure पे कौन से phases exist करेंगे, उनके बीच में equilibrium होगा. So many other information, how many variables are needed to explain that particular system, that can also be specified. So this is a very good system. Even though we have not constructed system, ढेर सारी systems को अलग-अलग नहीं construct कर रहे हैं, but still once we have experimented and we have drawn the graph of the water system, we are able to predict the conditions which might be on number of phases, number of variables that might be present in that particular system. Now we have talked a lot about advantages. We must talk about the limitations as well. Limitations is applicable to those systems which are in equilibrium. First and foremost, equilibrium is essential. Only 3 degrees of freedoms are allowed to explain the equilibrium system, because when we draw a graph x, y, z axis में ही हम उसको draw कर सकते हैं. And the same condition, temperature, pressure, all phases must be present. It consider only the number of phases rather than their amount. This is very important. We are just considering the number, we are not considering the amount. So this is a brief description of the phase rule. I hope most of the things, at least you have an idea about it, so that you can apply it on higher cases and higher level. And thank you all.